Our project was on the late Ordovician glaciation. So what was it? The late Ordovician glaciation is the first part of the Andean-Saharan glaciation. This is widely considered to be the leading cause of the Ordovician Silurian extinction. The late Ordovician glaciation had many effects on the Earth's climate and its inhabitants. So when did this glaciation period occur? The beginning of the period ranged from about 458.4 million years ago and lasted until about 443.8 million years ago. This glaciation experienced two specific extinctions. The first event occurred around 443 million years ago, with roughly a 1 million year gap in between the two extinctions. The second stint after this was an Earth warming at the end of the Ice Age, throwing off colder climates worldwide. So what were the major changes that occurred to the climate? The hydrosphere experienced a decrease in water levels around 50 to 100 meters and densely accumulated in the South Pole. The accumulation of frozen water turned into a massive ice cap called Gondwanaland. Scientists believe that deep ocean circulation experienced a significant increase throughout the unfrozen parts of the oceanic hydrosphere because of large amounts of water being cooled from Gondwanaland in the South Pole, as well as evaporation. The cold water was denser and sunk to the ocean floor, compacting the sediments. So, how did the late Ordovician glaciation affect living organisms? The biosphere took a detrimental hit during this time. Organisms like plankton and nekton would not have been able to survive during this glaciation because of toxic waters. During this glaciation, oxygen-rich water sunk to deeper depths near the ocean floor. And with this time at hand, plankton, zooplankton, and even phytoplankton were able to thrive in the oxygen-rich water. But slowly, as temperatures increased towards the end of the period, cold water currents began to move north. So, what were some climate feedbacks that occurred during this time? An example of a climatic negative feedback affecting changes during this time could be the freezing of water and the deflection of heat resulting in colder temperatures. The more the heat is deflected away from Earth, the colder the global temperatures, thus leading to more ice formation, resulting in even colder temperatures globally. As Gondwanaland shrunk, more heat was absorbed by the Earth from the sun, causing temperatures to increase, resulting in a negative feedback with less ice equaling an increase in global temperatures. So, what were some climate proxies that occurred? Doctoral graduate student Paige Quinton led a team to collect rock samples dating back to the Ordovician period. Scientists know that present-day Alabama was positioned on the edge of a shallow tropical seawater shelf of North America. Knowing this, Paige took his team down to examine rock samples to do carbon dating tests back to 450 million years ago. During their research, they found marine life to be rich due to the carbon-rich sediment samples. Paige and his team are not sure what caused this mass burial, but have proposed a large algae bloom came about and died, sinking to the ocean floor and taking other organisms down with it. So how are the changes that occurred in this period similar to today's climatic changes? In both periods, sea levels are rising, Arctic glaciers are shrinking and melting, and wildlife is being pushed to the brink of extinction. With the knowledge we know now about the Ordovician period, the late Ordovician period, and the last 150 years, we can see a positive correlation feedback with temperature and carbon levels. As our current carbon dioxide atmospheric levels rise, so do our global average temperatures, as shown during the late Ordovician glaciation. When carbon dioxide is depleted globally and atmospherically, temperatures will drastically drop. And lastly, how are they different? Earth has been observing its carbon dioxide and temperature patterns over the last 150 years. During the Ordovician period, the globe experienced an abundant rich atmosphere and organisms thrived, which in return accelerated the carbon cycle. But with the burial of vast majority of marine sea life, carbon levels began to drastically drop. With this carbon drop, the Earth experienced global cooling. And in the last 150 years, human activity has completely accelerated the amount of carbon in our atmosphere, which in return has raised our global average temperature. Another difference is we as humans have a strong will to curb this global warming with the right efforts. We can do something to reduce our carbon footprint.